Hi everyone, today's lesson is a combined lesson. It's lessons 42 and 43 together. A lot of different just quick math topics to cover. Nothing that we need to spend tremendous time on in particular, but just a lot of quick things to review and just touch on. So we've combined them all into this one day. So in lesson 42, we're going to be talking a little bit about short division, what that is, also the divisibility rules of number 3, 6, and 9. And then I'll flip over to this set of slides here, lesson 43. Sorry about this. And we're going to be talking just a little bit more about mixed numbers. So more arithmetic with mixed numbers. Yesterday's lesson, or the last two lessons, we've talked about mixed numbers, where those come into play when you're working with quotients in word or story problems. We're just going to continue a little bit of work with those. So let's take a look here. Our learning targets for this lesson: review long division, and then just using these divisibility rules to decide if a number is divisible by 3, 6, or 9. Why is that important? Well, if you know these divisibility rules, and really they're just things that you're going to memorize, if you know those, it's going to save you a lot of math, because you will have problems that show up on tests or homework assignments that will give you just a random number like 246. And they'll say, is this number divisible by 3 or 6 or 9? And if you don't know the divisibility rules, the only way to find out that answer is to actually work out the problem and do the work and decide, is that number divisible by a given number without a remainder? That's one way to check your work. If you know these rules, though, you don't have to do that. And remember, math is all about finding shortcuts, finding tricks on how to skip the long, tedious work. So I'm going to scroll down here. We're going to start off this lesson by talking about short division. Long division is something that we've practiced for a while. It's something that we will continue to practice by adding more numbers to the divisor and the dividend place. Long division is something you should feel fairly familiar with. Short division is this new concept today that we're going to be talking about. And I'm not particularly fond of this one myself, but it's really, my feelings aside, I think it's really important still to share this with you. To me, basically, it's just doing long division, but doing some of that work in your head. So a lot of times for visual people like me, it's really helpful to have the numbers down on paper, to see everything carry down, to make sure that you're not missing anything, to make sure things are aligned. But if that's not important to you, if you tend to be someone who likes to solve things in your head, you probably are already doing something like this and didn't have a name for it yet. Short division is just that. I'm going to walk through a long division version of this and a short division. So let me get my pen ready. 56 divided by 4. Remember, that's how you read this problem. Do not read this as 4 divided by 56. You read the dividend first. 56 divided by 4. Well, 4 can go into 5 once, and that in fact is 4. 5 minus 4 is 1. We still have a space left here, so we're going to bring down our 6. Can 4 go into 16? Yes. 4 times 4 is 16. And we end up with 0. I'm kind of off the screen there. We end up with 0. Our answer is 14. Okay? And let's take a look here at the short division version. Obviously, we have the exact same problem, 56 divided by 4. We're just not going to show as much work on paper. Some of it we're going to do mentally. So here's how short division looks. Actually, one moment, I'm going to zoom in. So in short division, we're still asking ourselves the same question. How many times can 4 go into 5? Well, still just once. But now we're going to start to do some work in our head, which is why it's called short division. We're not taking the time to write things out. In my head, I know 1 times 4 is 4. If I think about this, if I think, well, now my next step is subtract. 1 times 4 is 4. So if I envision like a 4 here, 5 minus 4 is going to leave me with 1 left over. Instead of writing that all out, I just do that math in my head, remembering that 5 minus 4 is 1, and I'm just going to carry that 1 up right here. I know it's kind of small and it's hard to see, but now my work there is done. Now I have to fill this space here, and now I'm just asking, how many times can 4 go into, there's my 16. 16. How many times can 4 go into 16? Well, 4. 4 times 4 is 16. 16 minus 16 is 0. All done. So it just is less work on paper. All right, so the next topic that we're going to touch on in lesson 42 is the divisibility rules of numbers 3, 6, and 9. And here they are. I don't have any other advice for you other than just do your best to memorize these because it's going to save you math in the long run. Divisibility test by 3, 6, and 9. A number is divisible by these numbers if 3, if the sum of its digits is divisible by 3. And when I say sum of its digits, I mean we're looking at like a 2, 3, 4 or more digit number. And the sum of the digits means we're adding those digits up to test these numbers. So we're going to add up the values of those digits. So if the sum of the digits is divisible by 3, then that number is divisible by 3. I'm actually going to jump to 9. So that's 3. I'm going to jump to 9 here. 9 is the exact same rule. If the sum of the digits is divisible by 9, then that number is divisible by 9. Now let's go back to number 6. 6 is just like one more tiny step. A number is divisible by 6 if, number 1, it's an even number. So with that being said, an even number also means it's divisible by 2. So you could say either thing. It's even or it's divisible by 2, and the sum of the digits is divisible by 3. It needs to have those two things. So sum of the digits is divisible by 3, and the number's even or it's divisible by 2. I'm going to scroll down and we're just going to do one quick example together and apply all of these divisibility tests and determine if this number is divisible by 3, 6, or 9. So the number is 456. Pause your video, see, because now that they're off the screen, here's another quick glance at these. Sum of the digits divisible by 3, sum of the digits divisible by 9, and then the rule for 6, divisible by 3 and 2. Give this a try. The number 456, decide if it's divisible by 3, 6, or by 9. Unpause when you're ready to check. All right, so I've written out this number as kind of a number sentence or an equation of the sum of the digits. So I've taken 456 and added 4 plus 5 plus 6. And when I do that, the sum of the digits is 15. So this is like this magic number that I'm going to be looking at. So now, let's decide if it's divisible by 3. If the sum of the digits, so 15, is divisible by 3, then the number is. Is 15 divisible by 3, meaning can it be divided by 3 without a remainder? 15 divided by 3? Yeah, the answer is 5. So is 456 divisible by 3? Yes. Yes, it is. Let's apply the rule for 9 because that, to me, is the exact same rule but just with a 9. So the sum of the digits, 15, is that divisible by 9? Can 15 be divided by 9 without a remainder? And the answer is no, it can't. This number, 456, not divisible by 9. Let's check 6. The rule for 6 is, if the sum of the digits is divisible by 3, it is. Remember, we decided it's already divisible by 3, so that's a go. The other thing we need to check is this an even number, or is this number divisible by 2? The number ends in 6. Yeah, that's even. So, in conclusion, 456 is divisible by 3 and 6, not divisible by 9. All right, so I've gone ahead and jumped over to my lesson 43 slides. I'll be attaching both of these lesson slides to your notes in Google Classroom. But just for the time's sake of our video, I'm going to jump ahead to this slide. I said that this is going to be more arithmetic with mixed numbers. There are 7 slides here in this set of notes. I'm not going to go through every problem with you just because I have combined 2 lessons today, and that gets to be a lot. But I pulled out 2 example problems that I think could be valuable to practice. I'm going to take a look at example 2 and example 3. All of these problems will be in your notes though, so they are there for you to review if you'd like to look at them. Example 2 says this. At home, Mario uses a bread machine to make bread. To make 3 loaves of bread, Mario uses 7 cups of whole wheat flour. How many cups will Mario use to just make 1 loaf? So we need to be considering he needs 7 cups for 3 loaves of bread, but what if he just wanted to make 1 loaf of bread? Think about that. Without giving you too much more information, I want you to pause this video and apply an operation that you think is appropriate in this case. We know that we're going to be ending up with a mixed number as an answer, but please try this and unpause when you're ready to check your work with mine. All right, so I've set it up like this. I have 7 cups of flour divided by 3 loaves of bread. If I do my math like this, I'm going to find out how much flour is used in each loaf. So I'm going to start by asking myself, how many times can 3 go into 7? And that is 2 times. 2 times 3 is 6. 7 minus 6 is 1. Now we've started writing our quotients as mixed numbers, and we know that we're working with mixed numbers today, so make sure that your quotient is in the form of a mixed number. We're not going to write 2 remainder 1 cups of flour. That doesn't make sense anyway, right? So 2 and we have a fractional part here. Our 1 goes all the way to the top. 2 and 1 third. Each loaf of bread requires 2 and 1/3 cups of flour. That seems about right. I make bread sometimes. Didn't mean to write over my answer, but 2 and 1/3 cups of flour. Let's do one more example. A whole circle is 100% of the circle. If a circle is divided into thirds, then each third is what percent of the circle? I wanted to do this example with you today because I had been noticing in people's homework lately that I was getting just fraction as an answer, and percents can absolutely be fractions. In fact, in this case, it will be. But I want to just reiterate that it's important if they're asking you what percent, make sure your answer is in the form of a percent, meaning you have that label. Go ahead and give this a try and unpause when you're ready to check my work. This is a type of problem where some people would really benefit from drawing a diagram, and if that's you, definitely do that. I've set this up as an equation. I have 100% of a circle divided by 3 sections. That's what they've asked us to, or they said divided into thirds. And so I'm going to go and do this work, and then just remember that when I write my final answer that I do include the percent, because we're being asked to find the percent of each third of the circle. So 100% of the circle divided into thirds. Well, can 3 go into 1? No. Can 3 go into 10? Yes. 3 can go into 10 3 times. 3 times 3 is 9. 10 minus 9 is 1. We have another spot to fill here, so that's why I started to bring down my 0. I'm going to bring down my 0 here. I have the exact same problem I just did. Can 3 go into 10? Yeah, 3 times. 3 times 3 again is 9. Remainder 1. So we're not going to be writing remainders anymore. So we have 33 remainder 1. Instead of writing it like that, I know that today we're practicing writing things as mixed numbers. So I'm going to set up my fraction. My remainder is 1. That gets brought all the way up to the numerator's place. My denominator comes from this divisor on the outside. 33 and 1/3%. Each third of that circle is worth 33 and 1/3%